Okay, so hopefully everybody's all signed in. We'll get started here just so we're on time. So good morning and welcome to the Online Help Center for BC Small Water Systems 2022 webinar series. My name is Jennifer Beverly, an Environmental Health Officer with Interior Health, acting as the moderator today. So as we begin, I'd like to recognize that I'm currently living on the unceded territory of the Ktunaxa and the Secwepemc Nations in beautiful Invermere, BC. If you'd like to take a moment to reflect on and acknowledge the traditional territories in your region, please type that into the chat box. And again, we do have Natasha Scott, who's acting as our IMIT help. So if you're experiencing any technical difficulties, please type your question into the chat box and Natasha will give you a hand. So the Thompson Rivers University with their partner hosts are holding this annual webinar series dedicated to providing relevant technical information, resources, and tools to small water owners, operators, and First Nations. So we will cover issues of water treatment, regulations, operations, maintenance, and monitoring for small water systems. At the same time, we hope to provide a forum for small water suppliers to share information and knowledge with each other. The Online Help Center strives to assist all small water systems in BC to implement a multi-barrier approach to drinking water in order for systems to consistently provide safe, potable drinking water to their communities. So this webinar series will be hosted every 2 months in 2022 and is offered free of charge. For attendees who are EOCP certified operators, each webinar will count as 0.1 CEUs towards your certification. After the webinar, a certificate of completion will be issued to webinar participants, and then you can submit that certificate to the EOCP if you'd like that CEU. So today we'll have a presentation on wildfires and their effects on drinking water systems by Dr. Whelton. Dr. Whelton is a professor of civil engineering at Purdue University and a director of the Center for Plumbing Safety. Dr. Whelton's expertise focuses on environmental chemistry and engineering, emergency events, polymer science, infrastructure, and public health. He has 20 years of experience in the academic, private, and military sectors. So this presentation will focus on the topics of wildfires and their effects on drinking water systems. Dr. Whelton will share his insights and experiences on wildfire emergency response and recovery. After Dr. Whelton's presentation, there'll be an opportunity for a Q&A discussion on emerging wildfire concerns for water systems. So if you do have questions during the presentation, please type them into the chat box and we will go over them at the end of the presentation. So let's get started and welcome Dr. Whelton. And I will just give him control to share his presentation here.
All right.
That looks good.
Can you hear me?
Yes.
Great. Okay. Well, thank you very much for the opportunity to be here and share with you some of the on-the-ground field experience associated with wildfires in drinking water systems in the U.S. I thought that this approach that I'm going to provide today is a way to kind of bring you up to speed on what we've seen down here in the lower 48 with regards to new threats that we've just become aware of in 2017 about wildfire contaminating drinking water systems, specifically distribution systems, avoiding watershed damage, but actually contaminating the distribution system, where the treatment facilities are fine, the watershed is fine, but the structures are destroyed or damaged in the system that results in depressurization or plastics, thermal degradation, generating contamination in the system. A lot of this work has been based on our firsthand experience in the field, and I've broken it up into a couple of phases. The first phase of this presentation focuses on what we've known until this past December 2021. Then I'm going to share with you some understanding about our work in Colorado during the Marshall Fire, the most destructive fire in Colorado's history, which occurred at the end of December of this year, and then kind of big takeaway messages. So whether you're a small water system, a very small system, representative, or a medium or larger size system, or a government entity, you can understand like what your roles and responsibilities could be, or at least have some big picture idea about how the response and recovery should go. So in the US, public water systems, or those that are regulated, supply 25 people, 25 of the same people for 6 months of the year, and a small public water system serves 10,000 people or less. And so some of the systems that were damaged in fires in the US, of course, serve like 300 people or 1,000 people. So these are generally very small systems, and I'm sure there are some similarities to that in Canada. In the US, small systems serve about 78% of the US population. So in general, most of the US population is served by these small systems. Now, when fires occur, there are threats to different infrastructure systems. And so, of course, we have the homes and buildings and commercial businesses out here, and we have drinking water source. Excuse me. So this could be surface water sources like lakes, rivers, streams, creeks, or it could be wells. And we have a drinking water source, and we convey that water to the treatment facility, and we either have the treatment facility a centralized location, or maybe we treat at the wellhead, and we then send that water into the distribution system where it's stored and travels to the customers that it ultimately reaches. Now, when fires occur, historically, what we've thought about in the last like 30 to 50 years is that watersheds get damaged. So we burn trees, we burn vegetation and grass and other materials. And in these forested watersheds, after the fire, the rain comes and washes all that off into streams and other sources that causes contamination and fish kills and other long-term water quality problems. But there's really an infrastructure angle to this wildfire threat to water systems, and that is the actual physical assets of these materials and systems. So here's a pipe that conveyed surface water from a lake to a treatment facility in Boulder Creek, California. And in 2001, it was a high density polyethylene pipe that, instead of being buried below the surface, they ran it on the top of the surface through a forest. And so they did it to save money in time. And when the fire happened, it burned up that plastic above ground. We also have generators and other equipment and facilities at our treatment facility. Sometimes we might have well houses. Here we have an emergency generator that caught fire at a fire out in Colorado, which knocked out power to the water system. We have fire hydrants. We have pump stations and other types of materials that can become heated based on where the flame and the fire is located. We have storage tanks, and this is another example from Boulder Creek, California, where they lost pressure in their storage tanks, smoke got in and basically contaminated the inside of that epoxy lining. And they had to strip all that epoxy lining out and reline their tanks inside because they were contaminated. We have curb stops. We have water meters in these water meter boxes. And of course, we also have service lines themselves that sometimes pop up above ground in mobile home parks or near water meters and such, and then we have the buildings. And so there's just a number of different vulnerable points of a water system associated with fire. And these are not necessarily wildfire related, they can be structure fire related. But of course, when wildfires happen, you can have embers that travel 2 kilometers away from where the fire starts, and you can have spot fires that generate heat well away from the fire front. So for the very small water systems, you may have a single well with multiple homes on that well, and you may or may not have a storage tank. Here for well systems, you can have concerns about the fire can burn over the wellhead. It may or may not be inside a well house. If it burns in the well house and the well house falls into this open well, because some of these are shallow wells, you can have contamination. You can also have these casings They may be metal casings, they may be PVC or other plastic casings, and they can burn and melt down below ground surface. Out in the campfire in 2018, they saw about 10 feet below ground, the PVC well casing was melted just because it's so hot how it burned above ground. We can also have irrigation systems that are on private property or commercial properties, and those can burn, and then the contamination can actually get sucked back into the distribution system. So when fires happen, you can have sometimes chaos take over, where you have infrastructure burning, you can have pressure loss, power loss, and you can have contamination, whether it be soot or debris, start moving into your infrastructure or being drawn in, and then when firefighters fight fires, they can actually drag it around the system. And so this has generally been discovered since 2017 after the Tubbs fire in California. And that's kind of where we got involved. In 2017, the Tubbs fire happened in Northern California, and it affected a community that is in Sonoma County, and it burned into the city of Santa Rosa. And the city of Santa Rosa has a water system that serves 270,000 people. But the fire burned in a little bit and affected about 50 or 60 homes, burned all of them down but 13 of them. And they started doing testing after being notified that the water smelled funny, and found wicked high levels of contamination in their water system. I mean, they found 40,000 parts per billion of benzene in their water system. And only 5.2 miles of their 170-mile distribution system was affected. But that contamination was found there. And to kind of give you perspectives, in the US, hazardous waste is declared as 500 parts per billion of benzene. And so they were finding well over 500. They were finding 40,000, 37,000, some low levels as well. But they were trying to figure out, first of all, where it came from, how it got there, and then how to get rid of it. Because they had a lot of plastic service lines, and it turns out plastics suck up these contaminants like a sponge, and then when you put clean water in there, they leach them out slowly and can make the water unsafe in certain circumstances. So we got involved in the Tubbs fire because after 3 or 4 months of flushing contaminated water, and they were unable to reduce the contaminant levels below safe limits, somebody told the city of Santa Rosa to give me a call. In my work prior experience was working with the military on decontamination of infrastructure after accidents and kind of terrorist events. And so when you have bad stuff in your system, how do you get it out? And what's the best way to do it? And so once they told us what levels of contamination they had, we basically said, well, you need to start removing and replacing infrastructure. You cannot flush this away. It's too significant. And so they started doing that. And then fast forward a year later, after the campfire in 2018, which is the deadliest, most destructive fire in California's history, where unfortunately 85 people were killed, the City of Paradise called us and asked for advice about, so how do we find contamination in our system because it was so extensively damaged. And so just to kind of give you some perspectives here, the Paradise Irrigation District, or the water system for Paradise, served a population of about 26,000 people. And that was completely burned over, as you may have heard. And then there were some other smaller water systems that were affected too. Delaware Water Company, which is a private water company, owned a number of systems that served about 11,000 people total. Then there were mobile home parks and other small systems. Separately, there were about 2,400 private wells in the area, that were potentially affected as well during this fire. And so about 3 or 4 months after the fire, we got called in at Purdue to kind of help advise the federal agencies, state agencies, county agencies, and the utilities about what to do, what to look for, where to look for it, and what type of approach they needed to find and remove the contamination. And so so we went in, and unfortunately what happened initially was, because the damage was so significant, there were no samples really when we showed up. So there were 50 water samples at like 7 different water systems for a population of 40,000 people. That was primarily because so many people lost their homes and everybody was relocating, and the communities were significantly damaged. I mean, I think it was like 80% of the buildings in the town of Paradise burned down, commercial and residential, and 50% in these other communities nearby. The state assumed that benzene was the only chemical present, even though the year before they had realized through testing that benzene wasn't an indicator of contamination. A new group of people were leading the charge at the state here, and they made the decision that benzene was the only thing they needed to look for. We helped them out to try to figure out what chemicals they should be looking for, and came up with a procedure where they basically isolate their system, they pressurize it, fill it with water, let the water sit so the chemicals, if they're there, leach out of the infrastructure into that clean water, make it contaminated, then they take a sample, send it to a laboratory, and determine if it is or is not contaminated. And so basically we set up Paradise towards hunting for contamination in their 172-mile system. And they did that. This just gives you a map of the town of Paradise, which used to have a population of about 26,000 people. Every red dot is a destroyed building or damaged building. Every green dot is a standing structure. And they, of course, had significant damage in the area. And so when we did our inspections, we found that much of their infrastructure, their water meters, water meter boxes, even the service lines that were in the water meter boxes were thermally damaged. They used a lot of plastics for their service lines. Their buried pipes, they didn't really have any problems with because they were 6 feet below the ground. And so in Santa Rosa, they had some hydrants that were contaminated, but not many. In Paradise, I don't believe they found any. But they had hundreds of leaks, and there were 90% of their system was depressurized. Like they had no water in it at all for hours to weeks. And so, so this was a challenge, and primarily it's a staffing issue. Many of the utility employees were living in the area, and their homes and their families needed to relocate. And so that's what kind of slowed the response and recovery here. And they didn't really have much mutual aid, neighboring support in the area as well. And so this kind of shows you, the purple dots here shows you the standing homes in Paradise, and everything around it was destroyed. They had 7 pressure zones, which was a medium-sized water system, 172 miles of pipe. They had just replaced a lot of their water mains with PVC and a lot of their service lines with high-density polyethylene, that black plastic pipe. And so it was just a monumental effort to kind of go through and flush out their water system. In the area after the campfire, I think they had like 14,000 homes that were destroyed. In Paradise alone, they had 11,000 homes that were destroyed. And so as you can see, and if you've ever been near a wildfire, you can see, you know, a new fence was put up recently, you know, across from this damaged structure that was not affected, but then its damaged structure here was affected. So one of the issues we learned in 2017 and 2018, especially after campfire, is that government agencies in the decisions and the guidance they make is very important. So after the campfire, what we found was that the government agencies, the state agencies, for example, were dealing with different utilities differently. And what I mean by that is boil water advisories were issued by both this public utility and this private water company that were, you know, less than a mile from each other, and they were both affected the same way. And boil water advisories were issued because theoretically people assumed that bacteria was the only thing that you could get in your water. But what history has shown us is that chemicals like VOCs and SVOCs can actually find their way in and pose an acute health risk. So in 2018, boil water advisories were issued, and benzene only drinking water samples were collected by the private water company here on December 5th. And then they waited the 2 weeks for the commercial laboratory to turn around results. And what they found was that benzene was present in their drinking water system above the long-term drinking water exposure limits. Well, When the private water company found that, they told the public water company, and the public water company had no data because they didn't really have any personnel to sample. So they issued what's called a do not drink, do not boil advisory. So they don't want people drinking the water because it could harm them potentially, and they don't want them boiling it because VOCs are chemicals that can volatilize, volatile organic compounds, into the air, and then you would be exposed to them. So they created this do not drink, do not boil advisory that was not necessarily in the playbook of the Centers for Disease Control, but they developed it based on this chemical concern. Well, that approach, the private water company, Del Oro, didn't issue any advisory to their population except the boil water advisory, which they had lifted before finding contamination. In Paradise, which didn't have any data, but their neighbor found contamination, issued an advisory telling people not to use the water. So the state came out and said basically only you should be concerned if you smell contamination in the water, otherwise it's fine. This was kind of the first issue because, for example, benzene's hazardous waste limit is 500 parts per billion, and you can't smell it until it's like 2,000 parts per billion. So this is an issue where you have policy being made and issued that kind of gums up a lot of the response and recovery. So over the next 2 weeks, there was confusion because many of the people had family that lived in one of these water systems that received water. And it turns out that both water systems had hazardous waste scale contamination in them, whereas the public water system, Paradise Irrigation District, moved forward and basically told its people, do not drink, do not boil the water. We're concerned, they found it. In the private water system actually never advised their population not to use the water for drinking and not to boil it ever. And this is an issue in the US that we have where the regulatory agency didn't assert themselves and require proper notification of this community. At one point in late March, what happened was the county, so the local health department, not the state or the feds, the local health department basically had enough and said, you both have hazardous waste scale contamination in your water systems. We're issuing a county-wide warning that there's contamination here. And then later on, another state agency came out and said, basically, don't use odor as a indicator of contamination. And this state agency basically took the contaminated water that was unsafe for smelling, brought it to a state laboratory, and conducted a human subjects test where they took their employees and had them smell it. And there were reported symptoms of injury due to that odor, like throat constriction and other types of things. And so this was an unfortunate series of events, but kind of goes to the confusion and in how, in absence of kind of a methodical plan towards making decisions and understanding how to protect public health and also employee health, you can have a number of unintended consequences. So this here is just a warning I wanted to show you from the county health department, where the county health department issued a warning telling people not to use the water for drinking, cooking, food prep. And this covered both water utilities and private homes, because many times private homes were kind of left out on their own in this situation. So the reason why I bring this up to you is because I want to show that in the absence of good, solid, methodical advice protecting public health, you can have multiple agencies, saying different things, which will cause confusion and put populations at risk. We've come a long way from that. Here's just some of the data, if you're interested in the water quality data for the Camp Fire and the Tubbs Fire, and some of the chemicals that were detected and the levels that were exceeded. After a wildfire, from a chemicals perspective, you're concerned about the long-term implications, but really you're concerned about the acute exposure. What will cause you to have immediate health consequences? And that's really what should drive the initial decisions. And so this is where, for small systems, your government agencies can really help you, right? Because you generally don't have the staff. You don't have a toxicologist on staff. You don't have an environmental health specialist on staff. on your small water system. And this is where you can lean on your government agencies to kind of help you through this decision-making process. Where is this contamination coming from? We think it's potentially three sources. One is plastics, and we've done some testing, and I'll show you some data. When you thermally expose them, these plastic pipes and gaskets and meters, they actually decompose, they generate VOCs and SVOCs, and those can find their way into water. You can also have structures burning and other types of materials basically go into the air. These gases and vapors and particulates can get sucked into the system. They can mix with the water, and then they can basically bring contamination to your water system. And then we can also have is the hydrants and other types of structures. Sometimes firefighters, as they run away from the fire, they can't shut the hydrants, and so sometimes when there's depressurization or low pressure, the contamination can get in through those hydrants as well. We do know secondary contamination can happen, where you can have contaminated water move from one part of the system to another, and the contamination can then adsorb to the surface of that infrastructure, so your pipes, your gaskets, your tanks, or whatnot, or biofilms and scale. And then when you have clean water come in, it can desorb. So you don't necessarily have to have damage in that system, but you can have contamination in that part of it. And so we did a study to test out this theory. Can plastics be a source of drinking water contamination due to heating? And we didn't burn these plastics. We heated them up between 200 and 400 degrees C. And we did find, yes, in fact, benzene and other contaminants can be generated by these materials. We also, as I mentioned, looked at a number of different materials. We didn't just look at high-density polyethylene or PVC. We looked at PEXs, different types of PEXs, CPVC and polypropylene as well. And a number of chemicals are present. One of the issues is that building codes, and should you use plastics in certain applications that are potentially exposed to fire, they never considered the potential for wildfire impact, right? We have water meter boxes that are close to the surface. Should they contain plastics, or should they have concrete, or should they be copper or other types of metals? This is a decision that needs to be made in the future. Other issues is we don't necessarily understand the chemistry of formation. We know it happens, we've proven it, but there's a whole bunch of questions that need to be drawn out. And then some of the organizations that were involved in the campfire that didn't necessarily make the right public health decisions at the time subsequently went ahead, it exhumed pipes from Paradise and tested them, and they turned out to find out that benzene isn't actually the indicator of contamination. A number of different contaminants can be generated by heating these plastics, as well as it could come from uncontrolled burning of biomass like vegetation, trees and brushes that can get into the water system. So when it came time for making contamination and decontamination decisions in Paradise, we worked with the federal government here, and we're able to create a decision-making process where the table on your lower right there shows that, for example, if we have a benzene concentration in a drinking water distribution system of 100 parts per billion, 286 days would be required for constant flushing at 2 gallons a minute, a single water pipe, to decontaminate it back to safe limits. And so based on physics, math, and chemistry, we could basically predict how long it would require to decon something. So if you have only a low level of contamination, like 2 parts per billion, it could take 64 days of time to decontaminate that infrastructure. So this gives kind of some idea about how to decontaminate systems, and through numerical modeling and such, that you can actually implement in the field. It also helps for government agencies, and at least in the US, where we have federal taxpayer money going to fix these water systems in communities, where the federal government doesn't require testing of every single water pipe. So in Paradise, that's 16,000 water pipes that were potentially contaminated, and the federal government initially told the town that you have to test every single pipe initially to determine if it's safe or unsafe. They're able to do representative sampling to say, okay, we don't have to test 16,000 and we'll test 2,000. Okay, this many percent are contaminated, and so then they were able to get funding to fix that water system for the rest of the pipes that they didn't test, knowing what the sample size was and how many were contaminated. Now I'm going to show you a picture here and in a video, but this is really important to understand because one of the issues we keep running into is that if you have contamination in your water system, and we saw this in the Colorado Marshall Fire, if you flush out that contaminated water and take a sample, you're sampling clean water that should be clean. So you actually have to wait for stagnation. And so this would be the same situation that I'm showing you now, where we have contamination in the water system. Let's say you're a utility and you're trying to stabilize your water system and you're shutting valves and trying to get pressure back. So let's say you put water in the pipe, and what we have here is a contamination goes into the infrastructure. And now we flush it, we flush it, we flush it. And what happens is we have to stop flushing and let that water stagnate or sit before it's sampled. And this is because we need to wait for that contamination to come back out to detectable levels. You may be familiar with this like lead and copper sampling, right? If we flush water out of the pipe and we bring in clean water from the city or your utility system, it probably won't have any lead in it. You have to let it sit there for a little bit before you can find the lead. The same concept here for contamination after wildfires, except this is VOC and SVOC contamination. For systems in communities that are rebuilding, many people have questions. These homeowners have questions about, what types of materials should I use when I rebuild? How do I read a lab report? I went out and I paid $100 or $200 to have my water tested. I don't understand what this lab report's telling me. There's a big effort here that's needed post-wildfire where communities can rely upon local educational institutions, small system help centers, and provincial and other government agencies to help them understand how to work through these types of decisions. And this is what we've done in the past. In water safety attitudes is a big issue. And so while the utility is trying to test and fix and repair its water system, we can't forget about the residents who are kind of going through things on their own here. And so this is a study that we did after the campfire, where we see a resident, and all these black lines and arrows indicate who residents talk to for advice about drinking water safety. So people that had damaged homes, not destroyed homes, but damaged homes that they were living in, wanted to know if the water was safe and what they could do. And so on the left-hand side of this screen, you can see water use restrictions, plumbing sampling and testing, plumbing decon. How do I determine my plumbing is safe or unsafe? Water tank selections and maintenance, insurance company interactions, and design of new properties. And so all these questions and concerns exist, and many people will be going through these types of issues. Now, you also should hesitate to issue guidance about how to make this wildfire contaminated water safe in homes. And the reason being is because we saw this after the campfire, where the state of California told people to go out and get activated carbon filters and treat the water themselves because activated carbon filters can remove VOCs. And that's true, but as we know in engineering and science, blanket statements are generally a little bit dangerous to have. And in this situation, we took some of the filters that were being used by homeowners who invoked the state's guidance, and we found out that some of the contaminated water would basically pass through the filter and result in levels that would exceed acutely toxic limits that people would be exposed to. So after disasters, sometimes people rely on the refrigerator filters, they rely on these pitcher filters, they rely on all sorts of different devices because they want to bring some stability to their lives, and we just need to make sure that the guidance that's issued to them is based on fully understanding what the devices do and what they don't do so that people are protected from harm. Another issue that we learned after the campfire, unfortunately, as I mentioned, people were told to smell the water, not test it to determine it was safe. There are some issues when you have a community or multiple communities impacted that the governing agency or regulatory agency treats each utility the same and doesn't allow or provide different advice to different utilities, because this causes confusion and also can jeopardize public health. You're going to have people that aren't going to follow the water use restrictions, do not use order, do not drink order. It's just going to happen. Typically, there was a study after boil water advisories were issued in England back in the 2000s. I think it's like 20%, 10 to 20% of the population just won't follow it. You just got to keep plowing ahead with evidence-based guidance and making the decisions that you need to make based on the data that you have. And what I tell people is you need data to drive yourself out of the disaster. So you need to collect samples in a way that you characterize the situation that drives you out. And once you get that data, then you make the next decision to drive yourself through that process. A lot of people are going to be asking about inhalant treatment devices. We had Colgan, Aquasana, a number of different companies were selling their devices to homeowners directly, and also insurance companies, to try to get people back in the homes. But there's a ridiculous amount of money going into it, and a lot of the salesmen were saying things that weren't true. When we checked out the system, some of them were way over designed, $10,000 a home. Some of them were not designed well. The companies assumed that only 1 part per billion of benzene was in the water. And so you really, to help your communities, you need to understand, what levels of contamination is in the public water system that's being delivered to the homes, because only then and then can homeowners make decisions about what technologies they can use in their homes to make the water safe while you're restoring your water system. Some of the other lessons that we learned after some chemical spills elsewhere is you really need to go in and do testing as soon as possible. And we recommended the state of California after the Camp Fire, I think it was 2 or 3 months after we get involved, or once we get involved after the fire, that they need to go in and start doing testing. They waited basically until 11 months later to do testing, and the testing was only done in homes because a researcher was able to get a grant from a federal agency not associated with the state. And 11 months later, they found contamination still in homes. And so this is really important to understand is, this contamination can linger in water systems, and it's important that the public water system methodically march through and find it, isolate it, properly advise their community about what to do with support of the government agencies, and then do the testing as appropriate. Now, I talked a lot about the Tubbs fire and the Camp Fire, and you look down at the bottom of the screen here. There have been other water systems in California and Oregon and Colorado that have been contaminated after wildfires. The reason why I think you see so many systems in Oregon contaminated is because Oregon went out, the government agency, and funded free testing for their small water systems. So they helped their small water systems understand if contamination was or was not present, and they found it. We haven't seen that in Colorado. We haven't seen that in California either. So I'm betting that there is more contamination of water systems out there after fires, but the testing necessarily hasn't been done correctly. So one of the takeaways here is, after a wildfire, you should not only be concerned with bacteria testing, but chemical testing of the water system. And chemical testing of the water system is more than benzene. It's more than BTEX, this benzene, toluene, ethylbenzene, xylene, and it's probably more than VOCs, volatile organic compounds, but we don't really have a good understanding of that yet because there's so little testing associated with it. To kind of give you a caveat, methyl ethyl ketone was in a Oregon water system when benzene wasn't present, and methyl ethyl ketone was present at 138 parts per million, which exceeds the 1-day drinking water exposure limit here in the US. So chemical contamination is a new dimension to wildfire damage to water systems, and this is something that's probably always happened. Nobody ever tested for it. So with that, I wanted to kind of button that up and now talk about the Colorado's Marshall Fire is kind of the second half of this presentation here. And please feel free to take a moment and type in comments and questions in the chat. We'll get to those at the end of this talk. So Boulder County, Colorado is where the Marshall Fire happened in December of 2021. To kind of give you some perspective here, the pictures I'm showing are from Boulder County, Colorado. The county has about 330,000 people. The average cost, median cost of a home is about $127,000. The average income per person is about $120,000. The average cost of a home is about $592,000, and 62.1% of the population has a college education or greater, a bachelor's education or greater. To kind of give you perspectives on the U.S. average, U.S. population is above that, and Butte County, California is below that. And so that is where the Camp Fire was. And so that was our prior experience as well. So you can see this is a pretty affluent county, and there's a couple reasons for that in a highly educated county. So on the lower right, you see the Marshall Fire footprint. It was about 6,000 acres. And on the left are the Rocky Mountains. And so Boulder, Colorado, which is a city, is between the Marshall Fire footprint and the foothills of the Rocky Mountains. And all the red outlines you see there are prior fires since about 1923. And so that's all the footprint of the fires. And what I want to bring your attention to is this Marshall Fire happened, it leapfrogged Boulder and happened actually in a suburban area, not necessarily where people had thought fires typically occurred. And so what happened was on the left side of my screen here, where you see that flame is where the fire started. It kind of spread from left to right, and at 11:06 a.m. it started, and within minutes it was in Superior, and then it was also in Louisville and in Lafayette on December 30th. The three largest counties affected were Lafayette, Louisville, and Superior, but there were smaller communities within there. And the reason why this county is so affluent is because it's about 30 minutes from the state capital, Denver, Colorado, and it's about 10 minutes to Boulder, the city of Boulder, which is home to about 30,000 university students at the University of Colorado Boulder, NIST, government laboratories, and a whole bunch of commercial entities as well. If you know American culture down here, and I'm sure you have these and where you are in Canada, you know, Home Depot, Chuck E. Cheese, and other type of chain stores are located right on this Boulder County Turnpike where the fire was. And so there were 6 public water systems that were impacted, and they are the city of Louisville, the town of Superior, the city of Lafayette, which are those dotted lines, but then there were a couple others. So East Boulder County Water District, which is up there on the left, Sans Souci Mobile Home Park, which is down there on the left, and then El Dorado Artesian Springs, which is on the right-hand side as well. And so these systems were impacted by the fire. Now, to kind of give you some perspectives about, you know, how big these systems were, Louisville, Superior, and Lafayette had the largest number of people. In the big scheme of things, this fire was only 6,000 acres. So it wasn't like the Camp Fire, which was 153,000 acres. It did have some damage to different water systems of various sizes, water main lengths, hydrants, and finished water storage. The smaller water systems, East Boulder, El Dorado, and Sans Souci, didn't really have much finished water storage. They didn't really have many hydrants and such, and they were primarily groundwater systems. There was contamination in the systems. Louisville found VOC contamination. They found benzene at about 200 parts per billion. Superior didn't find contamination in their water distribution system, but they had watershed issues where basically got debris into their water watershed, their water source, and they pumped it through their water system that caused an odor. Lafayette did testing. They didn't find contamination, but they only had about 22 homes destroyed. In East Boulder, actually, here's a story here, had a paint thinner water odor, flushed that water out, conducted sampling, didn't find it, and then we came back 3 months later, 3 weeks later, we had a conversation with them where we found out that they had done this. They tested, they found contamination, and they had low levels of contamination later. So this is where, a small water system didn't necessarily have the technical capacity to understand how to take samples after a fire. So I'm going to share with you some insights about 3 of these water systems, these larger ones, just so that you have some idea about how things can go after a fire. And really, the first 24 hours, water systems are kind of on their own. So Louisville, Superior, and Lafayette here in Colorado were the 3 largest. As a fire came into the area, the treatment plants were evacuated. Louisville had 2 treatment plants. They had a south plant and a north plant. North plant wasn't affected, but the south plant was affected. In Superior, only had 1 treatment plant. And so fire embers came into the treatment plant area and actually burned down their generator. So at that time, they also lost power, and they called their neighbor Louisville and said, hey, can we open the interconnection and start receiving water from you so we can maintain pressure? Emergency was declared at 3 p.m. Evacuations were declared at 3 p.m. And the problem then was that the south plant lost power as well. And then the city of Louisville started getting calls from the fire department saying that there was low pressure at some hydrants. So operators actually drove into the fire zone with buildings burning around them, with power lines down, with debris and fire trucks there. And they basically climbed on top of these storage tanks because they didn't have SCADA anymore. They didn't have telemetry or any power for the systems, and found out that all their storage tanks basically had a foot of water left in them, basically almost complete depressurization of their system. So what they did was they basically shut the interconnection to Superior, who they were helping, so that they could try to maintain some pressure. And they basically tried to start refilling their system, but they did some calculations and they found out they were losing about 8,000 gallons per minute, which is an extremely high amount of water, primarily because of how many open destroyed structures there were. And as with time, as the fire burns through the town, you have a number of open destroyed structures which exceeded their capacity of production, so the treatment plant couldn't pump in enough water to keep just equilibrium. So they basically started shutting leaks and systems down. And the city of Lafayette, because they only had a tiny portion of their system affected, basically took hoses and connected backflow prevention devices and basically started sending water across the street to the Louisville water system as well. To basically start stopping the bleeding or the loss of water, these communities basically started shutting curb stops and other issues, entire streets and neighborhoods, they were shutting valves off to basically prevent water loss. Another thing that happened that kind of saved Louisville from complete depressurization was that the natural gas company, which had shut off natural gas to the area, and many of these systems had natural gas powered generators, so they couldn't power their facilities, drove a liquefied natural gas tank into the fire zone through the burning buildings and hooked it up at the treatment plant so they're able to restore production and able to restore pressure. So it was a pretty significant issue. A number of things happened here, but basically safety, power, and water pressure are the 3 issues that you see after fires in the first 24 hours. And so over the next several hours to days, people were shutting off these systems and trying to restore pressure in parts that were completely damaged, like entire developments. They valved them off to prevent contamination from moving back into the clean system, into their system that they were trying to stabilize. And so shortly after the fire, these are some of the pictures you see on the left, fire department there, but you see where basically water is spurting out of the foundation. This is where the house burned down, but there's still pressure. And so pressure is a good thing because that means that there isn't depressurization when you're having water in contamination getting sucked in. On the right hand, what happened here in Colorado was the fire was put out partially by snowfall. So the fire burned through Boulder County. Firefighters were able to get a foothold on it and start containing it and putting it out, and then it snowed. But when it snowed, that meant that the temperatures dropped, and you had basically frozen pipes in these basements that were still intact, basically failed in the pressure loss, so they had leaks there too. Another issue that Lafayette, the city of Lafayette did, which was great, which we recommend, is once you valve off these buildings, pull the water meter. And so we don't want people going in and turning their water back on because they could back siphon contamination to the water system. In East Boulder County Water District, the small water system did see that happen. So the city of Lafayette started pulling its water meters for all these destroyed properties, and they developed a system to do sampling. Now, some guidance that we provided to the community out in Colorado and Oregon, as well as California, is identifying which chemicals they should be testing for. So initially, after the fire, you're looking at safety, power, and pressure. And as you restore pressure, then you're looking at bacteriological integrity of the system. What happened in Louisville, actually, and I didn't mention this, is that they lost so much water and so much pressure that they were concerned that the firefighters weren't going to be able to fight the fire anymore. So they bypassed their treatment plan and allowed untreated lake water to enter their distribution system so they could have water to fight the fire. Now, when they did that, they put untreated lake water into their distribution system, bypassing the plant. They were concerned about bacteriological and microbial quality. They had to basically bring the system back and stabilize it with oversight of the government agencies, and they worked together to do that. Once you get that type of control back to your system, you have to go after chemical contamination. And this is where you have depressurization, localized or widespread. You have to know what chemicals to test for. And this is an issue. This is the list, right, that I'm showing you here. This is the list of chemicals that you should be testing for. Now, one of the issues that helped really the communities in Colorado respond to the fire was that they had helpful neighbors. And so large systems, small systems, all banded together, and even the systems that were outside the area basically sent in staff and circuit riders to help collect samples, open hydrants, flush hydrants, and really turn over the water systems within 4 days. That would typically take about 4 weeks to do. They also had mapping ability, and so for these larger, medium-sized systems where you do have IT staff, this is something that's very helpful. For the small and very small water systems, you need a map and you need a lot of copies of it so that the people coming in, you can teach and show what they should do for testing and what areas are off limits. So just to kind of give you perspective, like a 10,000-foot view of Marshall Fire in Colorado, what we have is 0 systems found bacteria. And I can say firsthand, I've been involved in at least 10 to 15 wildfires, and I have not found any systems find bacteria contamination. So I know a lot of people like doing coliform testing or E. coli testing, but more systems I've found have chemical contamination exceeding acutely toxic limits. And so I think we really need to stress this chemical testing post-fire as well. These very small systems, like this mobile home park, they lost power for 4 days. They had no generator. They had no storage tank. They also didn't have any fire affected. They just had wind damage. And so chemical testing there really wasn't necessary. The city of Lafayette, Louisville, and Superior had chemical contamination, or excuse me, fire damage to properties in their service areas. They needed to do testing, and they did. East Boulder County Water District, the small system that was out kind of away from the population, they had an odor, that was a sure sign that they had contamination, not necessarily the only sign, but they basically fell through the cracks because the state agency really was overwhelmed with a lot of other things. So this is where small water systems really need support, and state agencies can get out there and help them understand what they should test for, how they should test, and kind of the data that they need to validate that they don't have contamination in their water system. Here's some of the data from Louisville. It shows you on the left just a few of the chemicals of the many that were detected. One of the issues that these smaller and medium-sized water systems have is finding laboratories. When you call up a laboratory and you say, I need 30 samples, water samples collected for VOCs, I need EPA method 524.2 or 8260 run, the laboratories are not there necessarily to do disaster response. So this is where government agencies can really help out, either through their own laboratory until some type of commercial laboratory can be procured or not. In Colorado, they went through at least 4 to 6 laboratories, and I talked to several laboratories, and they said, we just don't have the bandwidth. We can't get it back to you within 24 hours. How about 14 days? Because we have these other paying clients that we got to get their samples on. So you really need to think about this, because this is a showstopper. You can't necessarily tell people when the provincial authorities say, everybody get back in your home, and you can't tell people exactly what to do with the water and such, and it causes a lot of angst. Superior had contamination of their water system, but it was primarily from their source water. It was a smoky ashtray odor water. It was sometimes, it brought concerns that there might be VOC contamination in the water, like, benzene, toluene, xylene, methyl alpha ketone, because at the time the odors were being reported, the town of Superior didn't really have any data. So they were kind of shooting in the dark about what types of contamination that might be there. There wasn't an advisory issued to protect the population from harm about this. And thankfully, it turns out that it was these less toxic compounds at levels that were determined not to be a health risk. And so, kind of give you just think a positive example from Superior. They have experienced a marshal fire on December 30th and 31st. The sheriff lifted the evacuation order on the 5th. The boil water advisory was lifted on the 6th by the state. So not necessarily the utility, the state actually issued that advisory, which was very helpful for these small water systems. The small water systems don't have the bandwidth, they don't have the people, and sometimes the people have homes and other things that are impacted that they can't do their jobs because they're doing these other things that are critical for recovery. And so they had these odor complaints. They sent out an email to all their customers that, hey, if you smelled anything, let us know on the 11th. And basically they got 200 complaints on email that they have an odor, they have a problem in their water system. So this was helpful in engaging with CDPHE, which is the Colorado regulatory agency. It helped bring the regulatory agency in to help the utility understand what's going on with this system. So it's very, very helpful. On the left is the East Boulder County Water District entry point to the pump station. They receive water from the city of Lafayette, treated water. Then they take it and they pump it to the storage tank on the left and pump it up a hill. They do not rechlorinate at all. They just monitor the chlorine system. And on the left is the San Suchi Mobile Home Park. They have their own well on their property. So finally, from a water system impact standpoint, we have wells. And I recognize many of the small water systems have single wells that serve small communities. I'm going to talk a little bit about private wells, primarily because there's some issues with understanding how to test for them and how to inspect them. Many of the small systems have them. So first, we encountered a small system in Colorado that used to be regulated, but because of a homeowner who's up on the top right decided to disconnect from the system, they basically fell out of regulatory requirements. And what we had here is we had a well pump into a well house where it was chlorinated and then went into the cisterns, and then the water went into this black line through the distribution system here. And it was a high density polyethylene pipe. And then there were a number of homes here. Many of the homes were destroyed, 7 out of the 8 homes, except for that one home next to the well. Now, the problem here was that this system didn't really know what to do. They had a local person that would kind of help and do testing. They had been doing like water sample collection and sending it for bacteria analysis for like 10 years periodically, but they weren't necessarily a certified operator. They didn't really have any training except on-the-job experience. And so they reached out to the county health department to ask what to do, and they kind of didn't even know they existed and such. So these are small systems and very small systems and even unregulated systems that do exist, that do provide water to very small communities that do need support after fires. Unfortunately, what happened was because they fell out of unregulated status here, they were not able to get any funding to fix their damaged water system. So as of today, their system doesn't work from the December fire. They have no water in it. Private drinking water wells and the buildings they supply can be damaged by fire, but as it turns out in the US, there's no consistency on what to test for. So if you look back, and we've done this, at all the guidance that's out there about what you should test for wells after fire. Well, there's shallow wells, hand dug wells, we've seen those. And there's also these wells with well casings that can be, 50 to 400 feet deep. And it seems like a lot of the US guidance tells people to test for bacteria or E. coli or coliform bacteria. And then there's a disagreement on what to test for after that. So in the US, there really isn't a good agreement on what to test for. We recommend people test for VOCs and SVOCs, and that's probably about per sample, it's probably about $400 per test. We did work with the Boulder County community and the health department to test actual wells to find out like what you would actually find in these contaminated wells. We visited a lot of these wells in Colorado, and as you can see here, probably a lot of these you can relate to. We did come across a hand dug well in Superior, right here on the left, and on the right you can see the hole and the water level in it. And then when we took a baler down there and we pulled out the water, we did find floating debris. So during these fires, you can have well houses and the other types of materials, the cover material, burn and fall into the well, and you can have contamination. This was a well from the 1800s. They used to have a well house on it and burned on top of it. Now, we didn't find any VOCs when we tested this very small sample population of these wells, but we did find SVOCs in some wells, and these were the hand dug wells where we primarily found it. So it's important to recognize that there's hand dug wells and wells with casings, and it's really important to do the damage inspection. If you have a hand dug well where the well basically collapsed on top of it and went into the well, maybe you should do some testing of that. You don't necessarily have to test every well that has a casing that's undamaged. But we did find inorganics. We did find localized inorganic contamination, lithium and vanadium. And this is primarily due to the geology of the area, not necessarily what, wildfire material got into the well. Now, a number of different county agencies and state agencies in the US have started creating fact sheets and guides. We're working with them to try to hone and make kind of a one fact sheet that rules them all, or guidance that rules them all kind of approach here. But it's evolved since 2017. One of the takeaway messages is after fires, the community is going to want to rebuild. Here, this individual who owns this property was rebuilding a shed on top of a disaster debris covered property. And so there really is a need to expedite your decision-making process and what to test for, where to test, how to test for. And it's generally not a good idea to go through that process as the fire has ended, you want to do that ahead of time. And this is where the government agencies that can provide some continuity is really important. For some people, they're just going to want to move on. And so you may see people asking about water system testing or contamination testing of the plumbing, months to even a year after the event has happened. So to kind of wrap this up, there's resources and ongoing projects that we have that you can have access to. First and foremost, at plumbingsafety.org, we have a wildfire resources tab where we post this information. So you can have access to a fact sheet about water safety considerations in buildings. I have that one slide that tells you what chemicals to test for after a wildfire, as well as water safety considerations for private wells. And so we find that it's really important that organizations that are involved in providing guidance are able to share information make the greatest hits of what they learn from other people. And so we find that in every community that we go to, that they learn from others and how best it fits their community and how to convey that information. Oregon Health Agency or the State Health Department came up with a how to test your private wells guidance. US EPA's federal agency here in the US came up with things to think about after wildfires and such. One of the issues in the US is who's going to pay to fix the system. And US federal policy, because of the tens of millions of dollars that has gone to fix water systems, realized that they need to take a position about water system components that can be heat damaged, like plastics, and how to best design systems and avoid replacing, make quick decisions about replacing them when they're in communities that have been damaged by fire. There's two other studies ongoing right now. One is funded by the National Science Foundation, NSF.gov, where we're basically manufacturing plastics, heat damaging them, to seeing how different additive packages and other types of materials impact leaching and chemical generation. And also, there's another project where we're working directly with utilities. So if you're interested in this, please feel free to reach out. We're working with directly utilities, making decisions, how to make decisions after fires, and what are the key things to think about. And finally, the last point here is, really the takeaway message is, if you're a small system or you're a water system owner, for you, maintaining safety, power, and pressure. You keep pressure in the water system, even if the structures are destroyed and you have water coming out of the system, that prevents stuff from getting into it. Once you start losing pressure, you start losing control localized of your system or larger parts, you may actually have chemical contamination. Once it gets in there, we're talking weeks to months potentially to decontaminate and test that system. Reach out to drinking water support agencies for advice. Isolate damaged areas. Sometimes you just can't control your entire system. You have to seed ground to parts of it because of your personnel, safety issues, or just the overall speed of that fire. And testing, again, is going to take some time. And so you can make decisions about if a system is affected, does it need testing or does it not need testing? So public health and regulatory agencies, this is where you have a profound impact on the ability of these communities that are attacked by fire in these water systems, and the personnel that are basically consumed, their time is consumed by fire. They may have their own homes or businesses in these communities. And so they may not have the bandwidth to make these types of decisions. And this is where I think you can step in and kind of help guide them through this process about what's helpful. Boil water advisories, I don't believe are relevant anymore. I think do not drink, do not boil advisories are important because you can have contamination in the system, and we don't want somebody boiling drinking water with 40,000 parts per billion of benzene in it, and being exposed to it. Damage inspections, I would encourage you to get out physically if you can and be there with the utilities. I mean, just seeing it and understanding the types of decisions that they have to make, the damage is really important so that you can go back to the decision makers at your entity or in press conferences that you were doing to help people understand what these communities are up against in terms of testing and speed, in which it's really important that you do that. The chemical testing and laboratory report is really a big problem. In Oregon, the state funded testing of these small water systems. That was amazing, amazingly effective, and is helpful. And that's important to do that early on. So with that, I am going to stop talking now and turn it back over to the Small Water Systems Center. And I appreciate you spending the afternoon with me. Thank you.
That's great. Thanks, Dr. Whelton. Some very interesting and helpful information there. So now we'll go to the questions. So please feel free to type them into the chat. I'll take a look through them and then I'll read them out for Dr. Whelton to discuss. So I'll just take a look through the chat here. So the first question was, at what depth do we no longer see wildfire damage to underground water mains?
So that's a good question. And there's a couple things. So first, if you have soil cover, ground cover, I think a new study came out recently by Oregon State University that indicated it's over 2 feet, 2 to 3 feet. But the thermal modeling that they applied assumed a certain fire of a certain intensity above ground. So if you have cars on fire versus timber versus just a forest burning, there's different thermal gradients that are subjected to that ground. And so I think the working theory is over 2 feet deep, you should be okay. I certainly wouldn't expect you to have thermal damage 6 feet below the ground with water mains. Now, that's the pipe itself. If we have fire hydrants that are metal, and we have metal barrels that go down, you can conduct heat. And so there are no really insulators, fireproof fire hydrants that protect the water mains from that. So there could be conditions where you could have localized damage to the water mains because the fire hydrants got so hot and conducted that heat downwards.
Okay, thank you. Next question. Do concrete pipes have any issues with chemical contamination or off-gassing after fires?
So concrete pipes would have the potential to absorb water, forget contamination. So they could also absorb contamination, but you have inorganic concrete and you have organic like SVOCs and VOCs. And so it wouldn't continue to permeate through the concrete pipe. I'm just thinking like stormwater pipes. You can have contamination of those, and generally, if you rinse it enough, it should come out. The issue is like dissolves like. So you have organic chemicals, and you have plastics, which are organic, and that's why they mix well. And that's the general issue that you have with plastics versus concrete or metals.
Okay. Next question. If water pipes have scale buildup from water hardness, would the water mains absorb and desorb the chemical contaminants differently?
That's a great question. So one of the theories we have is if you have scale, like let's say you have a high-density polyethylene pipe, but it's coated with iron because the service line is in a corroded ductile iron water system or something, and the scale is built up. If you have SVOCs or VOCs coming in, will they just interact with that scale, or will they go through that scale and get to the plastic and then go into the plastic and come out? So there really isn't that good of evidence out there either way. So generally what I assume is that if you have plastic pipes in the system, whether it be iron-coated plastics or hardness-coated plastics, you assume that there could be contamination until it proves you otherwise. But that's a great study that somebody could do. They could coat the pipes, put in contamination, let it sit, desorb it, put in clean water, and see if it leaches out from the plastic. That'd be a great study.
Okay, great. Kind of along the same lines, this question says, does water pH or corrosivity of source water affect that absorption process?
So water pH would affect, well, to our knowledge, water pH would only affect the dissociation of organic acids in the water. We're not generally concerned about organic acids. So the organics would have a proton, and at a certain pH, it would stay together, and at a different pH, it would kick off and be present as a proton in the organic acid floating around. So that only generally happens at certain pHs, generally not within drinking water ranges. So pH shouldn't affect it, but there haven't been good studies to really understand how pH would impact that process.
Okay. And I'm not seeing any other questions in the chat. If you did send it just to the panelists, I think Dr. Whelton would only be able to see it in his chat.
So I don't see anything in my chat, just so you know.
Okay. All right, we'll wrap it up then. Thank you again, Dr. Whelton. If you have additional questions after the webinar, oh, somebody just put in a question. We'll go back to that one. So the question is, my question is pertaining to the burning of cleaning wood debris after residential lot clearing, then burning the ash piles within a relatively close proximity to a small water wellhead. Our well is 175 feet deep. Buried ash piles are approximately 500 feet from the well. So I'll copy and paste that into the chat so everybody can see it.
And what's the question?
I think whether burning ash piles within 500 feet of a well could potentially contaminate it.
So there's two concerns. One is water runoff, and if the well casing is cracked, you could have it come in and debris or whatnot in runoff into the well, down the well casing. The other question that people always have is the groundwater going to be polluted? Are the contaminants going to make the groundwater polluted? And that would primarily be driven by the subsurface characteristics, sand versus, what other material you have there. So generally, we don't see that happening. There was a study after the campfire where they looked at runoff after the fire, and they looked at groundwater, and they looked at lakes and rivers. And after that first flush, they didn't see like long-term contamination coming into the groundwater. They did see, however, and this is interesting, I learned this. So if you had like a CVS or a Rite Aid or some type of like drugstore, that burned down, and all the medicine materials like went into the waterways, like right there, like ran off. And so I think, depending if you have like a creek intake or something, that would be a concern. But I don't think you would have like an ash burning pile be a concern. Of course, you could probably invoke your local health department. If you want them to like prohibit that from happening, you could ask them to write a letter and say, please go to this organization and say you can't put this ash pile this close or whatnot, if it's a municipality issue.
Okay, thank you. We're getting a few more questions in now.
Mhm.
So second question was, what about fire retardant in the water system? Any guidance on dealing with this?
So I have not seen any studies where they've looked at fire retardant contamination of a drinking water system. So we know people apply fire retardant by plane. We've seen it. And we know that sometimes water systems are depressurized, so they're sucking air into them through hydrants or some way else. But I haven't seen any study looking at the fate of fire retardant chemicals in the water system. I don't think nobody tests for it. So.
Okay, and then the last question here, could you expand on the thought that boil water advisories could be obsolete?
Yes. So a boil water only advisory, right? So a boil water advisory is what we think about in terms of like bacteria. So boiling it should kill the organism and activate it. And so that is something that we're very comfortable with doing for the last like 100 years. Main breaks, pipe breaks, didn't disinfect correctly situations, boil the water. And so we still could potentially have microbial issues in depressurized water systems. But we know that chemical contamination can also be present. And when you have water that may have bacteria in it and 40,000 parts per billion of benzene, and you put it on the stove and you boil it, you kill the organism, which is great, but you then cause the VOCs to go into the air. And that is an exposure that you have. And why that is an issue is because we're trying to, if we don't know what the level of chemical contamination is in the system, telling people to do something in that water is not protecting public health. That's not a conservative approach to protecting public health. So that's why you've seen in California and in Colorado these things called do not drink, do not boil advisories. So there's do not drink, do not boil advisory. It's one advisory, and it's telling people basically don't boil the water and don't drink it because they're concerned about the chemical exposure, that acute chemical exposure. And if a toxicologist can tell me that 40,000 parts per billion of benzene and all these other chemicals at tens of thousand parts per billion is okay to boil and there's no acute exposure, I think we're okay saying that a boil water advisory is protective. But I haven't found a toxicologist yet that's come to that conclusion. That's a study that could be done by a state agency or something where they can do modeling in that such.
Okay, great. So I have 5 minutes left, so I think we'll just wrap it up. We don't have any more questions, but if you do have additional questions after the webinar, the BC Online Help Center has a contacts page and an email address where you can reach us. So we'll just put that contact information into the chat box, but you can also see it on the website. We've also recorded this webinar and we'll post it on the Online Help Center website. As a reminder, you'll get a certificate at the end of the presentation. So just make sure that you're saving that certificate for any EOCP credits. Our online platform, the GoToMeetings and GoToWebinar, can't reissue certificates, unfortunately. So just make sure you save that. And we also have another webinar coming up on June 21st, where there'll be a presentation on chlorine and UV disinfection applications for small water systems. So please check that out on the website. So that's the end of the webinar, and thanks everybody for attending, and thanks Dr. Whelton again.
Thanks so much for having me.